Thank you and welcome to today's webinar. Our topic today is prioritizing indoor air quality post-COVID-19, part 2. Before we get started, I'd like to take a moment to go over just a few housekeeping items. My name is Nicole Sticka and I'm Vice President of Energy Services with the Greater Cleveland Partnership, and I'll be today's webinar organizer. We want to make sure today's presentation is extremely valuable for you, so we ask that you submit all questions by clicking on the question button in the control panel, and we will take those throughout the presentation. We do encourage questions throughout, so please do type those in. The Greater Cleveland Partnership has been dedicated to providing businesses with the most current and timely resources to aid businesses during this unprecedented time. I'm pleased to be moderating today's webinar as a follow-up to a recent webinar we held on indoor air quality. Today's webinar will take us deeper on the specifics of UVC and PHI. The previous webinar was recorded and can be found on the GCP InGear website. Today's webinar is also being recorded. We spend more than 90% of our time indoors, and the impact of building design and operations on human health is well documented. And a well-designed HVAC strategy can enhance the health and well-being within an existing space. Any establishment now needs to address its mechanical systems and the risk of airborne transmission through small particles, which may stay airborne for hours and can be transported long distances. Today, I'm joined by the Air Force One team, one of the Greater Cleveland Partnership members, who is also part of our contractors network. Today, we'll hear from Greg Guy, Brian Taylor, and Austin Nutter. Please refer to their bios on the event registration page or on the right side of the screen. First, we'll get started with Greg, who is President and CEO of Air Force One. Greg, thank you for joining us today. I'll hand it over to you.
Well, thank you very much. It's a pleasure to be here, and it's a pleasure to get a chance to talk with all of you about this topic. So I'll be very brief. I guess from my perspective, the biggest thing that I'd like to share is a sense of gratitude. I'm so proud of Ohioans for leaning in, especially the leaders of our communities, of our government, of our businesses, of our both nonprofit and public sector. I mean, it's just been wonderful to see everybody try to get to the right answer. And it's been a struggle, there's no question. You won't find an Ohioan or an American, for that matter, that hasn't been impacted by COVID-19. But one of the silver linings I find is that we are all equal. It has been a great equalizer for all of us, because we're all humans and we're all at risk, and we all just want to get to the right answer. And so it's been, I think, a neat opportunity to celebrate the frontline workers that get the job done for all of us every day. And they oftentimes don't get in the limelight. And this has been an opportunity for us to celebrate them and to express our gratitude. And so as we come out the other end of this, to the effect that this photohydroionization technology or any of the indoor air quality stuff that we're going to be talking about is helpful to you, then that makes me feel good. So with that, I'll pass it off to Austin.
Well, thanks, Greg, and thanks everybody for attending today. Just to get started here, and just to echo what Nicole started to say in the beginning of this webinar, please ask me questions early and often, and we'll try to address them in line of the conversation and the topic. Specifically today, we're going to be covering ventilation, maintaining air quality, and UVC photohydroionization, or PHI. Ventilation is essential to keeping people in your buildings safe. You do this through three main goals: controlling building pressure, which is the control of negative and or positive pressure in a building. If you have too much pressure, your doors blow open. If you have a negative pressure, it's hard to open your doors and the outside comes in. It also increases indoor air quality by diluting polluted or stale indoor air, and economizes proportion relief, and allows sufficient airflow to maintain healthy oxygen levels and CO2 levels in the facility. So maintaining air quality. Air quality plays a significant role for harmful pathogens. We know that air purification can reduce pollutant levels. Adding UVC and PHI is one of the few ways to properly disinfect air streams. UVC light will only mitigate the spread of bacteria and viruses that pass through the UV spectrum. And we're going to elaborate a little further as the presentation goes on.
Yeah, and Austin, I'd like to, one thing specifically, we talked about this last time, and I think it bears mentioning again. A lot of times the very first item that's disabled on air handlers, whether it's small or large, ends up being the economizer, whether it's because there's control problems, mechanical problems, comfort issues. Those things usually get disabled, either set manually or shut. And it's the first place to look when you're talking indoor air quality, is making sure your economizer or outdoor air dampers function as they're supposed to.
Correct. And I believe the CDC and the state of Ohio are both recommending to allow as much fresh air into your buildings as possible without affecting kind of that negative and positive pressure that we discussed earlier today, or earlier in the presentation. So UVC and photohydroionization, or PHI, reduces viruses, bacteria, odors, and air pollutants. So the question always is, how does it work? Well, it creates advanced oxidation processes. We call these friendly oxidizers, meaning that once these oxidizers neutralize a pollutant, they revert back to either oxygen or water. Germicidal UV rays have been used for decades in the medical industry, in the food packaging industry, to destroy germs, viruses, and bacteria. However, UV light is only effective in reducing airborne microorganisms that pass through the light rays. On the other hand, photohydroionization can reduce microorganisms by 99% in the workspace and on all hard surfaces.
Yeah, and that's the, Austin, that's the key. Although UV has been used for a very long time, it is a point of use disinfectant. The airstream passes through the UV rays. Anything that's in the UV rays becomes deactivated, and then it's supplied to your space, which is a positive thing. Where we get into an issue is, although that air is disinfected, once it's in the space where people are who are coughing, sneezing, just going about their business, it has no effect on the space itself. Now, there is UV that can be installed higher than eyesight to try to disinfect things that are on the ceiling and as they cycle through your space. But at the end of the day, it's not as effective as a photohydroionization or PHI system.
And we're going to kind of elaborate on this slide, but I'll ask Nicole. Nicole, has any questions come in thus far?
Not at this time, Austin.
I appreciate it. So we kind of want to unpack the technology itself. There's a lot of terms being tossed around and a lot of similar technologies. So we wanted to clean the air, no pun intended, and kind of get to the bottom of the technology itself. So ultraviolet C, or UVC, is a naturally occurring phenomenon where shortwave light goes through the ozone layer and into the atmosphere. Now, typically with UVC, it is completely absorbed by our ozone layer. Therefore, the germicidal benefits never actually reach us. So when we're talking UVC, we're talking about generating that wavelength ourselves. And then, Brian, do you have anything to kind of further the explanation of UVC?
Yeah, I mean, specifically UVC, which is the most effective on deactivating viruses. I mean, right now, COVID-19 and viruses are really probably what most everybody's most concerned and most interested on. When you're talking outdoor, the amount of UVC light that specifically gets down to our habitat is very little to none, although it is very effective. That ultraviolet light, when going through the atmosphere, helps create ozone and helps create hydrogen peroxide. So that's kind of slide us into the photohydronization process. And Austin, if you want to kind of dig into that.
Correct. And we kind of touched on it earlier today, but the UV reacts with a catalyst or moisture, and it produces these advanced oxidation processes consisting of hydroperoxides, superoxide ions, and hydroxide ions. We're going to kind of delve into that a little bit later, but we wanted to bring it up. There's also similar technologies out there, such as cold plasma bipolar ion generation and bipolar ionization. And really, at the end of the day, most of these technologies are quite similar. They both use positive and negatively charged oxygen or air ions to basically attract to oppositely charged airborne pollutants. But for the sake of this conversation, we will be sticking to photohydroionization or PHI. And Brian, did you want to add anything else about the other two similar technologies?
Yeah, I would like to delve in a little bit more. So at the end of the day, all three of these technologies promise to disinfect a space, disinfect surfaces, and provide a better indoor air quality, which they all do. There's no arguing that. Where the difference is with both of the bipolars. They create the positive and negative ions. Their effectiveness rate is slightly less than the photohydronization, and that it doesn't produce hydroperoxides. And I know people start getting worried about hydroperoxides. Is that good or bad for people? But these are naturally occurring oxides in the air. That's why this is specifically why the orders are to bring as much outside air as you can in, because that outside air has these oxidizers which help disinfect your space and also flush it out, where the bipolar and the ion, or the cold plasma bipolar and the bipolar ionization do not have that same effect.
So I want to ask Nicole, because I know last time this was kind of a hot button topic. Has anybody asked any questions in regards to these four technologies?
Yes. Is the UVC and PHI approach considered a green technology solution?
It is. Quite honestly, all three of these, the ultraviolet by itself, I can't say is considered a green solution. The other three, photohydronization, cold plasma, and bipolar, all allow you to reduce the amount of outside air that you have going into your space, as the process actually creates an environment on its own without the outdoor air that is a higher quality. So by reducing the amount of outside air, you actually reduce the amount of energy consumption if you were to install these items.
One follow-up question that I would have is, would you consider these in a layered approach? One greater effectiveness over the other? How should a typical office building, for instance, look at these technologies in terms of whether it's a hierarchy, cost, effectiveness? If they're looking at what technology do they really need to be budgeting for?
Okay, so I mean, that's a great question. So let's start with ultraviolet or UVC. UVC, like we talked about earlier, is point of use. It does have a positive effect on the airstream. Typically and traditionally, it's installed in front of the coils, specifically the cooling coil, to direct light onto the coil. So since the cooling coil, whether it's DX or chilled water, it's a constantly wet coil, so it has the ability to grow mold, bacteria, and things of that nature. So the UV light directed on that and the airstream keep that coil from growing and becoming part of bad air in your space. That being said, again, once that air makes it to your space, yes, it is good air, but it has no effect beyond that. Where the other three on here, and I would rate them all similar, PHI, the cold blast or cold plasma, and the bipolar. They're installed downstream of the equipment, so they're on the supply duct, and they supply air that actually actively works in the space, and as it gets returned back to the unit, can actively work on your coil the same way UVC would be. So if I was going to install something, it would be PHI, UVC, really at that point in time would be extra cost. It doesn't need to be spent. And that would be the same for the cold plasma or bipolar.
Great, thank you. No further questions at this time. You can
And
continue.
then I'll add one thing before I move to the next slide. I mean, I think for most of these, they use UVC with a catalyst to generate these friendly oxidizers. So you can have UVC standalone, but the other three technologies are kind of combined into one.
Right.
So UVC and PHI, or UVC and cold plasma bipolar ion generation. Just wanted to clarify a little bit there.
Yep.
So the manufacturer that created the PHI technology was founded in 1985. In the year 2000, it was developed and released, and since then has been approved by the UL, the TUV, the EU, the USDA, as well as the US military government, TSA, and I will stop there because I think that's important. There are airplanes that are outfitted with this technology. I'm sure the industry's wishes that they had it installed on all planes. I know right now there's a mad dash. The thought is when you enter the cabin of the airplane, you get hit with the oxidizing mist and you're sterilized before you get back into your seat.
Right.
As well as PHI cells are specified in the norovirus and the MRSA protection plan.
Right, and something I would like to add, Austin, is that although bipolar, PHI, and the cold plasma are similar technologies, we feel strongly that the PHI shows the most promise when it comes to disinfecting the space, long-term disinfectant, and the positive effects on the space with oxygen generation during the oxidation. So I kind of want to get that out there. We have access to all three. We prefer the PHI process.
And this was important to us. This product is made, designed, and engineered in the United States down in Florida. And I just figured that's worth noting. So, Nicole, do we have any additional questions that have floated in?
We do. Do any of these solutions impact the useful life of mechanical equipment? Great question.
Yep, solid.
Yeah, very good question. The short answer is no. Because you're installing on the downstream side, I know there's always concern with anything that generates UV or any other oxidizing chemicals or whatever you want to call it. Is it going to break down plastic and things of that nature? And there is a problem with UVC being installed on coil systems that have plastic drain pans, where if it's in direct view of the UV, it's at such strong wavelength that it will actually very quickly turn to plastic brittle. With the bipolar, PHI, and the cold plasma, it's on the supply side, and there are no negative benefits on equipment. Actually, they would be positive because the air coming back would be cleaner and keep your coils and things in better shape when it comes to mold, mildew, yeast, and so forth.
And later in the presentation, we will show a quick installation so you can get kind of a visual representation on how these units are installed.
Yep.
Was there any other ones, Nicole, before I move on?
Yes, there is. Can PHI actually make you sick? For instance, those that suffer from asthma or any other respiratory illnesses?
No, there's actually research, and that's something that we can share that's actually on the contrary. Because it oxygen enriches your space. Now that's a relative term. It's not making so much oxygen that it's a a problem, but it's actually a better situation for somebody with those conditions.
Yeah, it's actually that's a common objection that we get. As we speak right now in my office, we do have a UVC PHI unit. I am asthmatic and I'm allergic to everything under the sun, and I breathe clearly here and never had an issue. And I have many people within the organization and others that I know that have these installed, whether it's at their office or in their home, and have had no long-term effects. If anything, everything's been positive. So.
Yeah, it's a win-win.
Yeah. A couple more questions. Have you read, and I don't believe the answer is out just yet, from the governor or from ASHRAE in terms of making any of this equipment mandated just yet?
No, I have heard nothing about mandating this equipment. I'm not so sure that would happen. I know ASHRAE's kind of been back and forth, but there have been no statements outside of increasing outdoor air and making sure that your filters are clean and that you're using a high quality filter.
Mm-hmm. And another question, are there any rebates or credits being offered for installing something like this? I'll take a first stab at that and say, from First Energy's perspective, unfortunately, there are not any rebates. I'm not aware of anything else. Austin, Brian, are you?
I'm not so sure about rebates, but these items do qualify for energy reduction items. So if you're talking about any EME type funding from Constellation, I think you're going to talk about something later on regarding. Sure. So it actually does help reduce energy costs because you can reduce the amount of outside air to just the minimum to keep positive pressure on your envelope. And they produce such a quality indoor air environment that you can minimize outdoor air, which is a huge energy savings.
Yeah, and to your point, Brian, one thing that I was going to mention in the closing is PACE financing is an alternative solution. It is commercial property assessed clean energy financing. We'll be having a webinar on June 5th that you can find those details in the GCP events listing. But PACE financing provides a fixed rate long-term financing to cover 100% of project costs, no upfront out-of-pocket cost, and it's on your property tax bill, just like a sewer assessment would be. And this equipment could be covered under that financing mechanism. So the benefit of PACE is that you get that long-term up to 25 years.
Yeah, and it is covered. We did verify that, Nicole.
Mm-hmm. Another question, do any of these technologies generate ozone?
PHI specifically creates H2O2, O3, and then Austin, what is the third?
OH.
OH.
Which is hydroxides.
Hydroxide. These are all friendly and not something that when people think of the ozone layer, we always get it's a little bit of negative feedback, but then once we start talking about it and then show the difference, it is definitely not a negative ozone. And I will say one of the competing technologies specifically uses that in their marketing. So take it for what it's worth.
Yeah, and I might add there too, anything, any kind of chemical compound in extreme excess is detrimental. This has been tested and proven to not generating anything outside of what you would receive or come in contact to outdoors.
Correct.
And one final question that also came in, perhaps you'll address this in terms of the type of buildings that this is most appropriate for or beneficial, but how does this work for larger indoor recreation spaces?
Okay. It's actually appropriate from all the way down from, your residential house, all the way up to the as large a facility as you could possibly think. There are many of these items installed in a lot of government and federal installations, as well as hospitals. So they scale, like I said, residential all the way up to your large industrial complex.
And we've seen a lot of interest and have quoted gyms, fitness facility, indoor, whether it's tennis courts or indoor baseball diamonds, and we've also quoted up to large arenas. So it really is scalable, like Brian said, from a residential unit or a mom and pop shop up to a 50,000 seat stadium that's indoors, obviously.
Austin, I know you're going to start getting into the lab results and specific scientific data, but if you can also be sure to answer the question as it relates to COVID-19 and the effectiveness of these technologies on COVID-19.
Yes, let's hold that in our back pocket for about 2 slides, Brian, and then we can kind of tackle that question.
Okay, thank you.
No problem. So lab tests. So here's a lab test in regards to MRSA. There was a hospital in West Palm Beach that was struggling with MRSA. They installed UVC PHI units and did a 2-year study. After the first year, they saw a 23% reduction of the spread of this, and then by year 2, 39%. They also took samples and tested it in a controlled environment, and after about 2 hours, MRSA's inactivation rate was 98% plus. So there is quite a bit of documented reports as you get into test results. Here's another one with H1n1 Swine Flu. Again, in a controlled environment, you turn on the PHI units. After 6 hours, the inactivation rate of H1n1 was 99%. And if you continue putting in those oxidizers into your airspace, you get basically maintain a similar level.
It's continuous disinfection. Once the space has been affected by the technology, to get to a 99%, it takes about 6 hours. From there, it stays at the 99% rate.
So let's take this opportunity to talk about COVID-19, because that's what's fresh on everybody's mind. And I believe we're including, or after this presentation, you'll get a list of test results, and you can see, I don't know, there's probably 20 different strains that they actually did this test on. But at the end of the day, COVID-19 responds the same way. They've actually taken this technology and repackaged it. There's like a conveyor belt UV system that sterilizes meat in the meat packaging industry, and they basically repurposed that when the PPE shortage came out and ran PPE through it, completely sterilizing the masks and other things. So,
and they were using the PHI technology.
Correct. And then there's other people that have been kind of using an H2O2 mist, and we'll go into H2O2 or hydrogen peroxide later. But that's also a very good way to disinfect most anything. And this is one of the friendly oxidizers that PHI generates. Brian, do you have anything to add to that?
No, you kind of handled it.
Okay. Was there any subsequent questions about that, Nicole?
Not at this time.
Okay, so I'll give you one more test and we'll move on. This is looking at bacteria, mold, and yeast, and it took a little bit longer, but after a 48-hour period, these 3 pathogens or pollutants, inactivation rate went to 97% plus.
And that is the entire space, not just the unit, not just the coil, not just the ductwork.
Right.
That's actually in the space where people function and work and operate.
And they're testing it on hard surfaces.
Correct.
So this is one of my favorite photos, just for the sheer fact that it shows the cute little blonde towhead kid, and they're sneezing. And what we're being told by the CDC in the state of Ohio is that we should social distance at the rate of 6 feet. That is because we have the data to know that this virus is not airborne. It is a respiratory virus transmitted through water droplets, aka sneezing or coughing. And in this test simulation, they were looking for oxidizers already in the air, ready to kill microbes at the source. Again, this is TSA tested, and this was a TSA developed test. And what they found is that within 3 feet, the microbes from the sneeze test were immediately reduced by 99%.
Yeah, that's significant in that because you have a continuous environment where oxidation can occur, the deactivation rate within 3 feet works with our 6 foot social distancing rules. So that's a pretty important piece.
Correct. So when we're talking the friendly oxidizers, we're talking about hydroperoxides in the outside air. And this is a naturally occurring phenomenon. The sun, as you know, is a large UV source, and it reacts with metals or catalysts in our atmosphere to create hydroperoxides. It's also formed by the action of the sunlight on water. It's the Earth's natural purification. It helps the outdoor air feel fresh and clean. And indoor air has no hydroperoxides present, so they tend to build up, and that's why we typically have a flu season in the winter, especially in Ohio, because we're all cooped up inside and not outside in the sunlight, in the UV, with those oxidizers present.
Right. And again, this ties in with current suggestions that we bring as much outdoor air in as we can. Although we are bringing in outdoor air most of the time on units, it's at a 5 to 20% rate. By time it gets to the space, you don't have enough of the oxidizers to actually help clean your space the way it would with this technology. I should say sanitize, not clean.
Nicole, I'll do a questions check.
Nope, not at this time.
Okay, so this is just a quick and easy slide. Hydroperoxides in products, where else do we find these? We find these in a lot of consumer products, the Lysols of the world, the Crest whitening strips. Clorox has a hydrogen peroxide line. And so we wanted to kind of show that this is nothing new. We use it to disinfect a variety of things. And so now we want to take this and dive into hydroperoxides or hydrogen peroxide in general. Hydrogen peroxide is one of the most powerful oxidizers known. It's stronger than chlorine. It can be converted through catalysis, which is what we were talking about with the UV interacting with metals in our atmosphere to create hydroxyl radicals, or OH. It was commercially used in the 1800s, or started in the 1800s. Municipal water, wastewater started treating in 1970s, and air applications began coming forward in the 1990s to generate these friendly oxidizers, and is now currently used in nearly every industry.
One of the things you'll note on the previous slide, all of those items are the eco-friendly, which don't have the harsh chemicals and bad things. That's because hydrogen peroxide, specifically to humans and mammals, is a easily metabolized into oxygen and water.
Mm-hmm. Okay. So installation. We talked about this a little earlier. Brian mentioned that we install it on the supply side, but here's a visual representation of a UVC PHI unit installed on a build-up air handler. It's installed on the supply side of the ductwork. This particular unit has 2 dots. That's because that unit has 2 UVC PHI cells, so they're indicating on. And then the right image, you can see the UV light shining. Obviously, the oxidation part of it, or the friendly oxidizers, is at the molecular level, so you won't see that, but you can see the blue light. And Brian, did you have anything to kind of add? Actually, I'll let you kind of talk about the installation.
Yeah, the nice thing about it is that it's very easy to install it. It's basically you cut a hole in the duct, insert it, and then it kind of flange mounts, as you can see with the panel. It's universal voltage, so it'll go from like 90 up to 277 volts. And even at the lowest voltage, the highest current is like 2.2 amps. Typically, it's well below an amp, so it could be used off of the already existing control circuit on the air handler, so you don't have to run extra power or pull a circuit off of a panel board and bring it over. It can be used right in line of the equipment. So it's very convenient.
And one thing I forgot to mention throughout this presentation is that we interlock these to your HVAC system's fans. So if the fan is commanded on, then the UVC unit will run. So depending on how your HVAC equipment is scheduled, this will run in conjunction with that. So common questions, and as we figured, a lot of these questions came up during the presentation. How much does it cost? Which actually I don't think has been come up in the webinar so far. Is it safe? Does it actually work? So let's start with how much does it cost, and this kind of goes into Nicole's question, or one of the participants' question on, indoor facilities. How big does this scale? And that's really what it comes down to with cost. It could be something as cheap as a smaller, furnace with a DX condenser outside. That's probably around $1,500. Or you could talk about a fully built up air handler in a large arena, which may cost $10,000 per unit. It really depends on the HVAC system. There is some roundabout numbers that we can give you, but at the end of the day, it does vary. I would say it starts at about $1,500 per mechanical system. Brian, do you have anything to add on that point?
Yeah, it's not necessarily a linear scale either on the cost. So as you get larger, the increase in cost is much less than your starting point. And it's very dependent on airflow. We've talked about it the last time in terms of tonnage. Tonnage, you can surmise airflow, but that's not always accurate. So airflow is by all accounts the most accurate way to determine the sizing, the amount of power you're going to need, and the installation cost.
And I think this kind of plays into the next question: is it safe? And by doing the due diligence and finding out the tonnage of cooling capacity, the CFM of the unit, we properly size those UVC PHI units, so we're not undersaturating the space nor oversaturating the space. Potentially, if you oversized it, maybe 3 or 4 times, it would be potentially unsafe. So make sure that your HVAC contractor is sizing appropriately if you are looking at some of these technologies. And the last question, does it actually work? It does. We have loads of data that suggests it does. Now, would I rely on it 100% as the magic bullet to stop COVID-19? I would take the advice of the state of Ohio and the CDC and add these protective layers. All these measures you put in place, because at the end of the line, you mitigate the virus. So, it doesn't mean that you can put these units in and not surface disinfect, not social distance, do not wear masks. We still recommend following everything that's been set forth, but with this added technology, the likelihood of spreading and transmitting COVID-19 is dramatically
Reduced.
or decreased, I should say. Do you have anything to add to that? Nicole, do we have any additional questions?
We do, in fact. One question is regarding the HEPA filters. Are they effective if you are utilizing them in each room of a building?
That's a good question and a loaded question. So,
Right.
As we talked about on part one, there was this initial blast from the state. They had a PhD from Ohio State talk about adding HEPA filters to all of your equipment. The first problem with that is all of your equipment is designed for a certain filter pressure drop. So that puts you in a certain range. And typically they're going to refer to that as a MERV rating, like a MERV 8, which is kind of standard, decent filtration, but not anywhere near a HEPA filtration. If you were to take that unit and add a HEPA filter or even a high MERV that's not quite classified as a HEPA, you could drastically reduce your airflow or take your airflow to nothing. And at that point in time, you're not moving air into space, you can't heat, you can't cool, and if those items try to operate, it'll end up causing damage to your heating circuits, cooling circuits, and so forth. So that was a very dangerous push by the state. And I guess secondly, to filter the virus at the virus size, which is like a 0.125 micron, would require HEPA filters that would probably cost more, or a HEPA system, right? A fan, filters, and rack that would cost more than your equipment does that you have sitting on your roof now. Anything less than that will not stop the virus from moving through your air system if it were to become airborne. At this point in time, the only airborne ability is if it's in an aerosol, which means the really fine part of a sneeze, which probably doesn't have the ability to travel in through the return, through the filters, all of the coils, and then back out the supply side. Although making sure your filters are clean and high quality is important when it comes to reducing allergens.
And how about maintenance on these systems? What's the longevity of them, and do they need to be replaced at any point in time?
20 to 25,000 hours is the baseline for how long the cells last. So continuous operation about 2 years. On a typical system where you're occupying and unoccupying it, you could easily get 5 years out of a cell. And the cells are very neat and easy to replace. You don't have to disassemble the equipment. You pull the panel off and they actually slide out directly through the panel, and pretty low cost maintenance, and it could be applied right to your current PM agreement, and you wouldn't have to worry about it.
And another question is it cost prohibitive for an environment that has 25 plus RTUs?
It depends on the size and depends on the areas that they serve. That would be one that we would, whoever your provider is or us would want to look at, see how that's set up, and then come up with the best plan that makes the most sense on the value side. And Austin, if you have something to add to that.
Yeah, I mean, we've provided a lot of these solutions to people across the state, and typically it is more economic if you have like a built-up mechanical system or built-up air handlers. Just in some like small worship centers or churches, they might have 20 to 30 separate units. Then it may get a little cost prohibitive, and then you might want to take a look at what areas do you want to sterilize. I know that in the church environment, the worship center, it's where you're actually going to church. You know, that's the main focus. So if you have 24 units, well, and 2 of them are actually in the church, then I would probably spend your dollars there if you're short on budget.
Right. The other options are they sell this technology in other packages. I mean, we specifically talk about the duct mount side on the light to heavy commercial industrial side, but they also have flush mount wall units that can work in a space and handle X amount of square footage regardless of the amount of air handler. So again, that's where you have to take a look at the actual application, the equipment, and how the space connects and joins. And there's other ways to add some value to it rather than just throwing it on every air handler or a rooftop unit.
Last question, what's the availability of this technology today? Is there a lead time, whether somebody's working with an existing contractor or has a PM, a preventative maintenance agreement, is there a lead time on this?
There is a lead time. Typically, it would be 5 days. Right now, we're looking at, I think, 15 is the minimum that we would be willing to state. That is because, you know, of course, Air Force One and GCP are not the only people looking at some of these technologies. The hospital systems, industrial side are also very, very keen on trying to protect the best way they can. So lead times have went up, and although we do have promises that they're going to come down. So I would say 15 on an average, 20 days on the extreme.
Okay. And another question that came in, although we're discussing air quality today, what about other systems like water systems to mitigate, treat post-COVID-19? Are there any specific technologies that businesses should be considering at this time?
There are technologies specific to PHI for water systems. That gets into a whole different animal, and I think the scope of that discussion is outside of this. But there is the ability to treat water systems pre and post filter with PHI and other water technologies.
And then if we're talking about you know, mechanical cooling or hot water or boiler water, chiller water, then you would probably recommend doing a typical water treatment program with your PM.
Yeah, and that's the most effective. Again, to get all of the water to constantly go through a UV stream on that large of a quantity, and then guarantee that it maintains that quality once it's in the building. You're better off going with a more traditional water treatment plant.
Great. No further questions at this time. You guys have anything final that you want to conclude with before I wrap up today's webinar?
I mean, I personally just want to thank everybody for coming out, whether it's your first or second time. I'm glad that this resonates for you and it's something that you're considering or looking into. And I recommend that if it's something you have additional questions, feel free to reach out to GCP and or Air Force One, and we can help you navigate through these difficult times.
Yeah, I concur, Austin, and I guess the other piece and why we participated in this webinar, there's a lot of misinformation, there's a lot of myths, there's a lot of people trying to sell what I would consider a placebo, whether it's just UV by itself or filters by themselves. At the end of the day, there's multiple technologies and there's multiple ways to combat this. Although UV is good, like we talked about for coil disinfecting, and although filters are good for maintaining the internal air quality from a dust and allergen standpoint, when you start talking about the virus, it really narrows down the list of technologies and their effectiveness, and that's where the PHI and ionization processes really kind of come into play. So when you're talking to your current provider, make sure they're talking about something that's actually going to do something in the space rather than just give you peace of mind.
Great. Thank you to our speakers today, Brian, Austin, and Greg. Now more than ever, you can quickly understand that your building should be incorporating an integrated disinfecting approach to enhance the health and well-being for optimal air quality. Lastly, I had mentioned earlier, you may be considering how you're going to fund these specific technologies that you didn't necessarily budget for last year as we came into 2020. So I do encourage you to register and tune into the June 5th webinar on PACE financing. Again, that's commercial property assessed clean energy financing. It's a lesser known alternative financing strategy, but it does provide you that ability to have a fixed rate long-term financing up to 25 years, and it'll cover 100% of these project costs. So again, I'd like to thank today's speakers. Thank you all for joining us today. This webinar was being recorded and will be available within the next day or so. With that, thank you again. Be well and stay safe.
Thank you.